Not so stubby areas are often used to inject external prefixes. Prefixes from another routing protocol into OSPF. We're going to do that, but first we have to set up the area itself. My fake customer has asked us to configure area 34 as a not so stubby area. No special requirements or restrictions, just the vanilla NSSA configuration. We'll start out on R3 and perform what is probably the simplest configuration yet. Router OSPF1 network 10.0.34.3 0.0.0.0 area 34. Notice I'm using the specific wildcard mask here. We'll do area 34 question mark, and ignoring the little glitches on my terminal screen here, I'm going to do NSSA for not so stubby area and hit enter. And that's it for R3. So far it seems really simple. Now let's jump over to R4 and do the same thing there. Router OSPF1 network 10.0.34.4, all zeros, area 34, and then area 34 NSSA. After a moment, the adjacency comes up. We can go ahead and verify this further with a do show IP OSPF neighbor. And this gives us the neighbor's RID, the state, and the designated router status. So that means we're done, right? Well, let's check the link state database. Do show IP OSPF that. And wait a minute, we don't have any type 3 summary LSAs. This is a huge problem now because the router cannot reach other routers in the OSPF topology. So what's going on here? Well, let's take a look back at the topology diagram. Notice that area 34 borders area 23, but what is the rule about OSPF areas? All areas must be logically connected to area 0, but here area 34 is separated from area 0, so what can we do? Well, OSPF has a feature called virtual links, which are designed for this very situation. A virtual link allows you to join areas together by crossing a normal area called the transit area. Remember that all OSPF areas must be connected to area 0 because of the two-level hierarchy OSPF imposes. But if we take a look at the topology, we can clearly see that area 34 is connected to area 23 and not area 0. This is why area 34 is missing the type 3 summary LSA. A virtual link allows us to connect area 34 to area 0 by crossing over area 23, which is going to be the transit area. Effectively, a virtual link tunnels OSPF packets across the transit area. In fact, you can use something like GRE tunnel instead of a virtual link if you wanted to do that. A virtual link is configured on both ABRs in the transit area, which in this case are R2 and R3. Also, the transit area cannot be a stub area, because it must have full routing information. So let's go to R3 now and set up the virtual link to R2. Here on R3, we're already in OSPF router configuration mode. The command to set up the virtual link to R2 is area 23. Virtual link 2222, that being the router ID of the virtual link neighbor R2. Now keep in mind that you have to use the router ID here, not the IP address of the R2's interface. Now we need to go ahead and set up the R2. So, alright, we can see that R2 is complaining already about a mismatched area ID, but don't worry, we're going to fix that. Let's go ahead and do configure terminal, router OSPF1, area 23, virtual link 3333, which is R3's router ID. And almost immediately the virtual link comes up. Now the real test comes now. Let's go back to R4 and check those LSAs once again. We'll go ahead and run the same command as before, show IP OSPF database, and boom, that looks much better. We have our type 3 summary LSAs thanks to our virtual link. Verifying your configuration in these kinds of situations is vitally important, so verification is critical.